Okay. Hi everyone, my name's Martin. I'm one of the developers that assists FEDSA with their mentorship program. Today we're going to be looking at programming fundamentals. Apologize for last week. We had a vote and it was meant to be CSS animations, but I messed it up. So next week we're going to be doing CSS animations. Today is going to be programming fundamentals. Okay, so let me just start screen sharing. So doing the programming fundamentals is quite important. I know it is a bit boring, but I want to get moving on to JavaScript and all the cool things that come with JavaScript, and as well as React, and even actually Vue and Angular if other people are keen on doing that. But we can't move on to that stage until we've actually just sort of done some basic beginner stuff that you do with programming sort of fundamentals. And I'm not going to be just boring you with the basics of variables and functions and all of that, but it's stuff that I've picked up through the years, studying at universities and at places even like CTR, and then just sort of learning. There's some stuff that people don't do. And it isn't sort of taught to people, and I feel that it's just a shame. There's these techniques and things that are available to us, and often with web development and the boot camps and all of that, you rush to get employed, that you don't end up looking at some sort of basic things. So that's what sort of the goal is, to look at these things, give you that sort of that edge, and in the future, I can promise you that some of these tools you will be using in the future. And then just to preface everything, there is going to be some systems design stuff we are discussing now. In the future, we probably will also go into systems design, but we will just be touching lightly on UML diagrams and such. Okay, so let me just have a look at my notes. Okay, so what we're going to be doing to start off with here is basic variables. If you want to ask any questions or anything of the sort, please just raise your hand or just shout, and I'll address it as we go along instead of right at the end. So to start off, we are just going to be doing the really basic stuff like variables and functions and all of that, but it won't last too long. It's just to mention sort of some, I don't know what you call it, tidbits or things that we've learned that it's good for you to know from the start. Okay, so the first thing when you're going to look at the basics is variables. So just make sure you can all see my screen, right? Yeah. Okay. Right. So
Yes.
first thing we're going to be looking at is variables. So what are variables? Variables are basically when you've got values, they can be dynamic values. So what's often taught when it comes to variables is like a box. So you've got this box. So just imagine there's your box here. And then anything inside this box, you can go put a value. So you can put a 4 inside there. And then now this box is going to continuously update. So you can go and put a 7 and you can just keep changing the values in it. But it's no use if we can't reference this value. So what we'll do is we'll actually we'll assign it to a variable. So we'll just say my number or my variable is equal to 10. So I'm going to take this out. So now we can actually change this value inside here. And my variable will show whatever we've assigned it to dynamically. I'm sure you all do know variables, so I'm just going into it very, very briefly. Okay, so the important part I want to mention about variables is that one of the hardest parts about programming is your variable names, coming up with the correct variable names. And if you read clean code, you will actually see that he mentions there that often he actually goes through his code multiple times to change the names of his variables just so that he can get better meaning. So when it comes to naming of variables, now some of this will be opinionated, but some opinions tend to be stronger than the others. When it comes to variable names, don't cut things short like this, like Moby for mobile. What benefit are you getting if you're creating a variable as Moby instead of actually using mobile? So let's just say Samsung here. You're not really saving any time, and it's actually making it you're costing more time, because when it comes to your mind trying to interpret this word, it won't automatically know what Moby means. So now you've got to sit and it's got to figure out what does Moby mean. Whereas if you had just had mobile, your mind's not going to go and think about what this means. It just knows that this is mobile. So this is going to add extra processing to your brain, if you will. And so you actually just end up losing time. And often people do see this. You'll see this in your junior developers. They will cut things short like this, and you're not saving any time by doing that. Generally, the rule of thumb is, and I hope I get this correct, is if it is 3 letters, then you can go and give it capitals like this. So URL, for example. But what is it again? I think if it's 2 letters. Sorry, I'm gonna have to come back to that one. I can't remember off the top of my head. Okay, so that's variables. Just make sure that your names have good meaning and people understand it, and don't shorten it. And if you do have to change your variables, that is just a normal part of programming. You do often have to go in and change it. And a quick one is that if you're on your variable, let's just say I am using it here, so console log mobile. If I am to go and push F2 on mobile, I can actually change the variable name like this. So let's just say new mobile, and I push enter, and then new mobile has changed. And this doesn't just work for this. This works for your HTML tags as well. So let's just say we have a title here. I push F2 and I just say new title, and then you can see it's actually gone and changed the name there. Okay, so that's just sort of basic variable stuff. I'm not going to go into like JavaScript variables and all of that. That's the later stages. It's just basic programming fundamentals. Any questions yet at this point? No. Okay. So now we're going to be looking at functions. Okay. So we know what variables are now. It's these boxes where we can sort of change the values inside that box, and whatever is looking at that box will get that value. Now, what are functions? So functions are basically like the verbs of the programming world where we do things. It's like an action. So when it comes to naming your variables, your functions, because they do something, you typically want to make it like an action in the name. So a very common one, like when you're doing an API call, you'll see people they'll have a function like do fetch, but sort of some other common ones, like when you would see programming examples, is people bake cakes. So you would maybe have something like bake cake. But so you can see that in these variable names, there is always this verb at the beginning. So you don't have to do this. It's, your code's still going to compile and everything, but this is sort of now a convention that's sort of expected in the web development world at the very least, where you need to have a verb before whatever it is that you're doing. So that's quite a basic one, but it's just very important. So then immediately now, when I'm looking at my variable here, I can tell that my variable is a variable because there's no verb attached to it, whereas here's a verb prefix, which is do fetch. So immediately my mind knows, even if I was to take all of this other text out of here and just have do fetch, I would know that this is going to be a function because there's a verb attached to it. And then just while I am here, you can see that it's actually got its own syntax highlighting here. You can see that your variables are blue and then your verbs are yellow. Your functions are yellow. And so what usually happens with your function is it just will perform a set of instructions for you, basically. Okay, so let's move on to some of the next ones. Okay, so now what we need to be looking at before we move on to the rest of the stuff is conditions. And this is the stuff that you first start teaching kids when you start trying to teach them programming. Conditions are why we're actually using programming. Is that so that we can do things dynamically. So, for example, you're going to be baking. You're going to be looking at your meal plan for the day. And then, so if the time was, let me actually get rid of all of this junk over here. So let's have a variable and we just set time and it was morning. Now what we can start doing with our conditions is that we want to handle different things at different points in time. So if the time was in the morning, then we want to have our breakfast. If time was sort of lunchtime, then we're going to eat lunch. And if time's after 5 o'clock, whenever, we're going to have our supper. Now, that's one of the great things about computers, that you can give it sort of this very, very basic artificial intelligence where it's making these decisions for you. And that's what these conditions are. So how would we sort of handle that? We could have maybe like had an if statement. So if time is equal to morning, then we can go and let's just say we would do breakfast. And so I'll just do one more here. If time is equal to lunch. So don't worry about the syntax. If you're still new to JavaScript, it's fine. This is more just about trying to understand these concepts. Okay, so yeah, you can see that now we're using an if statement, that if the time is equal into the morning, then we're going to do that type of condition. And if time is equal to lunch, then we're going to do that kind of condition. So this is what, when we're talking about conditions, is that we can handle things differently depending on what's actually taking place. So when we are using conditions, how would we normally use it? We would either use an if statement like this, and that's like if else, or it could just be an if like this. Let me just grab it like that. So there, now you've just got a basic if statement. It just checks one thing. And then sort of the sibling, I guess, to the if statement is the switch statement. And that's basically, it functions exactly the same thing as, functions exactly the same way as an if statement, except there's a default catch right at the end. But you can even just use an else over here. So let's just say we had an else here. This would be your default catch. So a switch is when generally you've got a lot of if statements. And if statements, when there's just a lot of them, it can start looking untidy. So what we start doing is that after, let's just say 5 or 7, I'm not too sure that if there's like an actual number, after a certain amount, we start moving to switch statements. So we'd have the same thing here, except we go and we do cases. So instead of saying if time is equal into that, we actually use a case. And in our case here, we say what we're checking here. So yeah, we were checking time is equal to morning. Yeah, we're going to have time is equal into morning like this. So then we can do the same thing, do breakfast. And then at the end here, we'll have a default case. And this is just where stay hungry, I guess. Okay, so that's just very quickly looking at that. Talita, how's it going? I know that you're still new to JavaScript and all of that. Is this going a little bit too fast for you? Okay, so don't worry about that. Hey, Jane. Right. Okay, so those are your sort of if conditions. What we're going to be looking at now are our loops. So I'm just going to just take all of that out. And loops will basically run over your time X amount of times. And that's so that you can repeat a bunch of actions. Usually, you know, when just trying to imagine maybe there's a factory and things are getting built. So the car comes in, car gets painted, car has stuff put into it, and then the car is finished being built. Now, you'd want to repeat that process for every single car. And now you can think of that everything. Like your whole day is based on a loop. You wake up, you do, you know, you have your breakfast, you go to work, and then you go to bed. It's this loop that's continuously happening. So we need to have loops. And just as sort of just a bit of like, fun fact is that a lot of this stuff is actually still the exact same way that programming originally was actually worked. We're still actually using the old caveman ways of programming. Okay, so let's actually have a look at some loops. So the first one is just going to be a for loop. I guess I should explain as we're going along. So a for loop's got 3 parts to it, okay? And what it does is it starts at a certain position, and then it iterates, or it counts a new one, and it just keeps counting new ones until it gets to the end point. Okay, so when it comes to defining your for loop, is that you start off where it actually is at the beginning. So this we should actually just call this index here. Usually people call it R, but let's just call it index here so it makes better sense. Okay, so we would start our index at 0. This is where we're going to start at. So we start at 0. Let's just write here, start at 0. Then we go and we give it our endpoint or constraint or wherever it's going to stop. So we're going to stop at, let's just make it 10. Okay, so it's going to go from start at 0 and it's going to count all the way up to 10. But now we don't know, it doesn't know how to actually count yet. Is it going to count in 0.1 as each step? Is it going to count as 1 or 2? So this last one here is we tell it how often, like how big the step is. So we're going to say that the step is equal to R plus 1. Another way of actually writing that is R++, but I'm not going to worry about that for now. So this is saying each step must be R plus 1. Okay, so let's just close that. Right, so now this code's actually going to run inside you each time. So what I'll actually quickly do here is I'm just going to console log R and then just run this at the bottom. Usually when you're running JavaScript, it runs in your browser. So you would just load that JavaScript file and it runs in your browser. But now how do you run JavaScript outside your browser? Like, I think you've probably wondered about this at some point in time. And the way you do it is actually very basic. You just use Node, which might not be installed, but just for this case, just so you know, the way that we actually would run this is with just Node. So I'm going to say Node. Just clear this so it looks better. So I'm going to say Node, and I'm going to have to get to where the file is. Assets. Oops. Okay, so I'm going to run it, and we're going to immediately have a problem because I'm doing like strange things inside here, I'm guessing. Yeah, okay, so what I've done is I've called all these variables the wrong name, yeah. Okay, so I called it index. Usually people are going to say, yeah, like this is the one case where you are sort of allowed to shorten your variables when you're using the index. But you should also be using a for of each. Okay, so we're not going to go into that now. Okay, so I've run my code now, and what it's doing is that each time it runs, it's logging out the value of index. So what it's doing is it's starting at 0, it's adding 1 each time, and it stops at this middle point where it gets to 10. So just to show you that it doesn't actually even have to count in ones like this, what you could actually have is you could actually count it by 2s. Don't think that's actually going to have the effect. Yeah, okay. So now it's actually what it's doing is that the for loop's actually iterating 2 each time. Talitha.
Sorry, I just wanted to know, like, where would you use this? Just I have context.
Yep.
Where would you use this formula, like on a web?
So on a website, like for example in React and that, actually even outside of React, wherever you would use this, it's because it's a loop. You would use it wherever you want to do something more than once. So is there anything on a website you can think of where there's sort of more than one item? Well,
like a slide.
Yeah, exactly that. So it's a slideshow of images is correct.
Okay.
Then also that that project that we just recently did. Let's see if I can just grab it quickly. Oh, what was it called? I can't remember. Rico. I don't have the link, unfortunately. Sorry. But like that website that we recently built out, there were all those product cards. If any of you are able to just drop a link, I'd greatly appreciate that. I opened it on my laptop, so I don't think I've got my links here.
Are you looking for the Figma design?
Or even just the built website, just so that I can use an example people are used to. Oh, amazing. Thank you, Tamira. We've got it, Okay, so let's have a look at the design that we had here. So I actually designed this taking into account that you are actually meant to loop and create these items. So that's actually a really good question there, because it's actually exactly, this is a use case for that. So where you see these product cards over here, the Contessa, the Supreme, Black Lotus, and the Beachcomber. What we did, if you did the JavaScript portion, is you build out this element with code. Then you loop through it to generate each item. So you don't have to go and actually generate or build the card out 50 times if there are 50 cards. So I guess let's just go back to say I had code here that created the card. So something like, I'm trying to think of something I could do here. Sorry, I'm not going to be able to write out an entire example, but so basically where you would loop on this site, where is it, Figma design? There's 3 here. So what you would have done in your code is you would have looped up to 3, and then you would have run like a function called like generate card, and this function would have gone and put HTML on the page, put card in the HTML. So about did you get my drift there? Where you'd basically loop through it and you would run a function as many times as needed. Yeah, cool.
Yeah.
No, it's no problem.
Thanks.
Then, now when you got a for loop, you usually know where it's going to end. This second variable, the parameter, we've told it where it wants to end. But now, what happens if you don't know where it wants to end? So what we use in that case is a while loop. Okay, now the while loop. Remember we spoke about conditions. So until something runs. So with the while loop, we specify a condition here when it must actually stop. So one that's common back in C++ days is flag. So I'm just going to say flag here. Now this is not a good name for this variable, because flag could just basically mean anything. But in this while loop, you would run until you've had enough, and then you would actually set this flag to false, so it stops running. So this while loop is going to run all of this code inside here while this flag is true. Let's actually just do it like this, while flag is equal to true. Okay, so it's going to run all this code in here while flag is equal to true. Cheers, Bandia. See you next week. Okay, so what do I mean by that? So first our flag is equal to true. Okay. I'm actually going to change flag here to be is finished. Okay. So now we've got a variable here called is finished. So I'm going to have to turn this into false. Okay. So while is finished is equal to false, it's going to run this code in here. So maybe let's just say that we actually wanted to count to 10. So we want this to run 10 times. So we're just going to have like an index here. So index is equal to 0. And then when this is actually running, we're saying index is equal to index plus 1. An equivalent of this is index plus plus. And then we will say is finished is equal to index greater than equal to 10. So now what will actually happen is that this thing will actually run inside here, and it's going to take this index and it's going to plus 1 onto it. Then it's going to check, is it finished? And it's not going to be finished immediately because index is going to be less than 10. So then it runs again. And this is just going to keep running until eventually is finished will actually have an index of greater than 10. So it will then be set to true, and this loop will stop running. So I know that's not the best example. Like I should have actually had something prepared beforehand. But when we get to JavaScript, a lot of this will be, like, we will have more focus on this. This is sort of just to just to touch on it basically. Okay, so this is when you generally don't know how many times we're going to run. And then we would go and set a flag, and then it basically stops. Okay, so doing fairly good on time here. Okay, then the last two are two basic ones that I just want to touch on. We're not going to go into heavy detail here. Is a string. So, like, I know, like string, it just seems super basic, but like still just got to cover it. A string is just basically a mixture of numbers and letters and characters, and it forms like one variable. It really just comes down to that, is that it's a bunch of values and numbers that sort of is exactly as you see it here. So if I had sort of, even like, let me just go and put this in here, 2 plus 3. This string is not going to equal to 2 plus 3. It's going to actually equal what the exact text is over here. So it's just a text format. It's not like a variable or anything of the sort. And then the last one is going to be an array, which is like a list. So I'm just going to call it a list. Actually, let's call it array. So I'm going to just populate it with some basic numbers. So an array is just a list of different values. So let's just say that you had a list of people's telephone numbers, and it was just a complete list of telephone numbers in it. Then it would be sort of like that, and then the next number, the next number, and the next number, and the next number. So this is an array. It's just basically just a list that is separated with these comma values. Okay. Now, that's all of the basics we're going to be covering at this point. I know a lot of it is sort of touching on it lightly. That's because it's going to go into our next point here, is that all of these basics exist in all of the programming languages. Like anything you can think of basically has all of this inside of it. And if not, they've got maybe another way of doing it. But it all comes down to your for loops and your if statements, and then possibly that way of doing it. So if you are able to learn to program in any programming language, probably bar just like a small handful, you'll be able to pick up a different programming language after just learning the syntax. It's going to be a skill that you learn, and it just applies to every other language that you're doing. So if you learn JavaScript today and you learn it very well, you could actually go and pick up C# and very quickly start understanding what the code is doing. There might be a few new concepts that get introduced, or maybe you find that there's tools missing in that language that you did have in JavaScript. But it all comes down to pretty much the same thing. So if you learn to be really good at programming in JavaScript, you're going to be able to program in any other programming language. Okay, so that's the basic stuff. It actually went a little bit over time for that. That was the boring stuff we had to get out of the way. So now what we actually be looking at is, the first thing we'll be looking at is a bunch of tools that will help you improve programming. And the first one is going to be Pseudocode. Okay, so I'm writing it over here, Pseudocode. I'm actually going to call it an MD file so that we can actually see some better representation of how it looks. Let me split it to the right. So what we got here is just a markdown file so that I could just make it look really good. So just pseudocode. Sorry about that, my dog's being strange. Okay, so what is pseudocode? Now, there's going to be a big focus on this. A lot of the programming that you go into, like when you're actually writing code and all of that, at the beginning, you shouldn't actually really be sitting at your computer and just going straight into code. It's just never a good idea. There is planning involved. There should be planning involved of you sort of plotting things out and sort of wrapping your head around the idea that needs to, like, what you need to build. Like, I'm guilty of it. I will just jump into code and I'll start coding something. But if you're trying to build a really professional project, you shouldn't just be jumping into code. And it's just almost always a bad idea. I wonder if I spelled that wrong. Okay, so what is pseudocode? So pseudocode is basically you go and you write your program in layman's terms. Like, it's just the basic instructions. There is quite a standard to pseudocode. Like, certain people want you to do things specifically, but I'm not going to be going into that. That gets quite complex. We're just going to be looking at really basic pseudocode. So I've got an example here, I think. Yeah, I do have this one here. And it's going to be a really, really bad example. So I'm sorry about that. So I've got this sort of bake a cake instructions here. So generally when you bake a cake, you measure your ingredients, you mix your dry ingredients together, you mix your wet ingredients together, and you bake. Unfortunately, with the pseudocode, yeah, this is just going to translate directly. So what you would do with your pseudocode is basically you'd break down your program into steps. This isn't such a great example. I'm trying to think of something else. Okay, I'm just going to continue like this. Okay, so actually, I'm going to give you a different example. Sorry, I don't want to mess you around. So what I'm going to do is I'm just do like a basic user login, where user sort of like logs into a website. So what you would do is you break down the steps that you're going to go through, and we're going to be talking about breaking down steps in a moment. Okay, so user logs in. So the first thing you're going to be basically doing there is your writer. Let's take that out. And we're just going to just say a pseudocode of user logging in. So what you would write here is that step 1, user clicks on sign in button. Sorry, user enters name. Okay, so this is actually becoming more like a use case or user stories instead of actually pseudocode. I'll give like probably after the session I'll try and actually just quickly conjure up like a really good pseudocode sort of to just give an example here, or maybe I can actually just pull up something with Google. So, but the basics of pseudocode is that you're going to write your code just using sort of the English language to write your code like this. So it all makes sense in a moment, especially when I start breaking down how the different parts work together. Okay, so here is pseudocode that's been just sort of basically straight off Google. So you can see here, this is where they're starting. They start on the loop, then they're waiting for the sensor data, and if data is found, they grab the sensor ID and status. So you can see they're actually just using English terminology. They're not actually writing code. When they're done with this, what they can then do is they can go to their code base. Then they can write the code for that wait for the sensor data. Then they can put their if statement in here and start translating all of that from the English language into code. Okay, so I'm gonna actually just keep that example. So I can't think of really any examples that make a lot of sense. And this is just gonna translate directly. I'm just gonna write measure ingredients, etc. Okay, so that is some pseudocode. We're gonna drop back to this in a moment. The next one I want to be looking at is variable diagrams. Trying to think where I should start breaking down. Okay, no, we're gonna look straight at variable diagrams. Okay, so you're gonna have to bear with me. This time I'm actually gonna be doing some handwriting, and it's not gonna look very good, but we'll move on to Excel after that. Okay, so what I've got here is nonsense code. It really doesn't do anything meaningful. All it basically does is it's got values and it just loops through values, and then at the end a total is output. So what I'm going to show you now, I think it was shown to me in CTI, if I remember correctly. I don't often actually, can't actually find a lot of information regarding it, but for me, this is really just a valuable technique. I actually use this probably once every 2 months when I struggle to understand something. So when you're like a really good developer and all of that, you aren't some magical genius that's just going to know the answer to everything. Often you're going to have to try and break something down to understand it. And one way of doing that when you don't understand what code is doing is using variable diagrams. Okay, so now, like, what does that mean? So let me just grab a screenshot here. Now, what it basically means is that you're going to go and work through your code away from your computer. I mean, you could sit in front of your computer, but basically what you're going to be doing is you're going to be working through your code line by line and trying to figure out exactly what is actually going on in your code. So let's have a quick look here at how this type of thing basically works. Okay, so what you do is each time there's a variable, so there's a variable here, each time there's a variable like that, you will write the variable down, so like value 1, and then you will put the value underneath it. Usually they put like a box around it like that, so I can't draw properly. So I'm gonna shift to Excel in a moment. But so let's just work through this quickly so that we can just sort of see what goes on. So you start by writing your line number. So at the top here we line number 1, and then you write the variable that you've got. So I'm just gonna actually write v1. I hope you don't mind, just so that it's less to write, and I put the value underneath it. Okay, so then I go to, is there anything else? Any other variables? No, there aren't. So I'm going to go to the next line here, which is line number 2. Now, we're basically acting like the memory of your computer. So normally when these variables are actually being processed by your computer, they're being held in memory, even using JavaScript. So what do we do now is that we have to keep whatever we have declared as variables. So we're going to write down v1 because at line 2 of here, we still have v1 as a value. So we're going to put v1, and we know that value is 0. It hasn't changed. But now we've got, on line 2, now we've got v2. Okay, so we're going to put v2, and that's also going to be 0. Then nothing else in line 2, so let's go line 3. v1 is 0, v2 is 0. And now we've got a total, which is also going to be 0. Okay, so then line 4, there's nothing that happens. Line 5, things get a little bit more interesting. We've got v1, v2, we've got total. I'm just going to put a t there, and we've got r. So this is 0, 0, total 0, and index is r. Now we get to line 6. Line 6, v1 is not actually going to take a value, but unfortunately it now actually becomes the same as what it is. So we're setting v1 to r. So we're setting v1 to r, but r is already 0. So v1 is just going to become 0 again. And then we just repeat this again, t0, r0. Line 7, we're finally going to have something change. So now we're on line 7. v1 we knew was 0. v2, we can see now v2 is this 10 here. So v2 is now 10. And then there's times 0 and then r0. Okay, now writing all of this, yeah, like on the computer and that, it just takes a lot of time. I swear on my life that, like, I promise you, like, it was just like last month. I went through a very complex e-commerce application doing this. And it still, to me, is a valuable tool. So what you can instead of doing it like this, is that you can just go and maybe use Excel or something of the sort. So you put your line number in here, and let's just say v1, we know it was v1. Let's actually just continue where we were. So it was at line 7, v1, v2, t, r, and then we had 0, 10, 0, 0. So now we go to the next line. I'm not going to pass through this entire thing. We get to the next line, which is line number 8, and we don't do anything over there because it doesn't actually enter this code block. I is not going to be equal to 2. So we jump straight to line number 12, and that is going to be total is equal to total plus the value of value 1 times of value 2. Okay, so we know that is 0, that is 10. Total is, sorry, we'll come back to total. So now our total is equal to 0 plus this times that, which is also 0. So this actually ends up being 0. Okay. Then next line is line 13. We go back to our loop because we check here, is r less than 5? And it is, so we carry on again. Now we're back to line 6. Okay, so I'm not going to work through this whole thing. It will take some time. If you all want, I can make a separate video where I just basically go through a variable diagram. But I think I'm gonna just see if there's any questions at this stage on this.
Yeah, when would you do this, Martin? Is this still part of the pseudocode, or is this like more for like debugging if
this is a separate thing to pseudocode. So pseudocode, I'll go back into that in a moment, and we might just run a bit short on time today, so I apologize. We're gonna go over time. So pseudocode is something that you would just go and break down your application so you can write it down in pencil in a way that a human can understand it. No code, nothing. You're basically planning your application out. This is a debugging tool. So it's just basically just two techniques I wanted to show you that, to me, there are two fundamental things you should always know about in programming, and they're just aren't taught. So this is when you actually don't understand, well, either one of two things I would say. Either you don't understand code and you want to understand why something happens. Like sometimes you can't just keep console logging values. You just go and console log, console log, console log. Like it's hard to wrap your mind around it. So what you would usually do is you would use this to understand an application, or alternatively, you would use it for debugging. And you can still do this, like you can actually do this through the actual application, like in your browser, you can step through your code, but this is still just a massively vital tool to have. Like you can be sitting on an airplane and you can debug your actual code. Okay, so there's that. Let me now just go and look at the rest of the stuff we've got. So I haven't caught up on the comments yet, but I think we're all good. Okay. I did this a little bit out of order, and I think I'm now actually going to step back and actually go over a part that I was sort of leaving for the end, and it's generally how you would typically actually program, how you would start programming something. I guess I should have actually opened up with this. Okay, so some of the stuff will probably be a little bit opinionated. So it's not 100% how you can do it. It's just hopefully it might, if you don't do anything like this, then it will hopefully improve what you are doing. Okay, so the first rule of it all is break down your problems into small little problems. I don't believe there is any developer out there, even that is the most sort of genius person that's ever sort of been born, that can basically in their mind wrap their mind around an entire application from beginning to end and know all of that information at once at one point in time. I just don't think it's possible. Like computers are just amazing for that. Humans not so much. So what I mean by that is I've got something here that I did. Okay, so yeah, is just say like it's a basic brief that I've now lost. Sorry, let me just do this. Okay, so you're given this task. You need to build an online store, and users should be able to add items to cart, check out their cart, and share their purchases with their friends. Now, you probably don't have any panic setting in right now, but I promise you, sit down and have this brief in front of you for work that you have to start doing today, and you're just going to have this deep sinking feeling inside of you. And everybody basically gets it. You will get these tasks, and it's just simply not possible for you to do all of this like it's written here. It's just not possible. What you need to do is you need to start breaking the task up. So immediately we can see that we're going to have users. So you know that there's going to be users involved here. You know that you're going to have a cart. And with that cart, you're going to have functionality. So let's just do this, like adding functionality, add to cart. Then they're going to be able to, like on the checkout page, so they'll be able to share their purchases, just share their order. So once you start breaking it down like this, it starts becoming more digestible for the human mind. And you can start sort of trying to understand what parts can you pull out, what parts can you start with today. So immediately, like if I look at this, I know where I'm going to start. I see that, okay, there's going to be a cart here. So I'm most likely going to start building out this cart. But not just yet. There's this other stuff I'm going to show you that you've got some planning you'd want to do beforehand. Okay, so that's this part here. Now the next thing is to do with a book that Jonathan was mentioning, which is a book that I love to recommend to people. It changed my mind completely. It blew me away. And I'm talking about just the first 20 pages. It's a book by I believe her name is Barbara Oakley. It might be incorrect. I will share it later. And basically, she says that anybody can learn math. I struggled with math growing up, and I just thought that I was too stupid for math. But basically, what it came down to is I just wasn't taught 100%. I didn't learn how to actually use my mind effectively. And then later on in my life, I actually went and learned math again, and I did really well at it. So, why is this discrepancy? And basically, what it comes down to, and this will impact you, I promise you, it impacts every single person, is that your mind has got two states. You've got an active state and you've got a diffuse state. Okay, so there's the active state here, and you've got a diffuse state. Now, sorry, it's not the active state. That's from programming. You've got the focus state and you've got the diffuse state. So if you learn, when you're at school, you learn that like 2 + 2 is 4 and 2 + 5 is 7. And you eventually learn how those numbers work together so that you don't actually have to sit there and count on your fingers 2 + 5 is equal to 7. So now when you actually get given like a math worksheet and you have to work through all the questions, your mind goes into this focus state and it just like nails those questions. It just goes 2 + 2 is 4, 5 + 7 is 12. It just goes through these things so quickly because it's in this focus state. But if I was to immediately have thrown like maybe a word sum into that while you're in this focus state, you suddenly sit there like, and you get stuck on this. You can't figure it out. And what the problem is that you get stuck in this focus state. And what you're actually supposed to do is you actually need to break away from what you're doing, take a quick walk, whatever, make some tea. And I promise you, in those 5 minutes, your mind's going to enter the diffuse state and you are going to solve that problem. You might not even actually be thinking about it. And this applies to not just programming, it applies to like anything that requires sort of like mental exercise. And you will find in programming what's going to happen, and I promise you it happens to people every single day, and just there isn't enough awareness around this, is that you'll be looking at a problem at your computer and you're just staring at your screen, thinking that you're trying to figure it out, but you are not. You basically, you've hindered yourself to only think in this very, very small box, and you're going to struggle to find an answer. Even though your mind is fully capable of solving it in like 2 milliseconds, you are going to be stuck in this focus state, and you're not going to solve it. So what you need to do is you need to walk up, get away from your computer even. Go and sit in your lounge and just pick up a book or whatever, and let your mind enter this diffuse state. Where basically it looks at the bigger picture. And what's going to happen is that your mind is now able to see things from all these, try and understand the problem. You're like 9 out of 10 times, you're going to find the problem within like 5 to 10 minutes. Okay, I can't promise those sort of time frames, but generally with me, like I walked away from my PC and within 5 minutes I've solved it, where I could have been stuck on this problem, not even lying, like for 2-3 days. And it goes past this. If you actually spend a lot of time thinking about a problem, your mind's also naturally going to try and solve it while you sleep. It's just what the human mind does. There's actually some examples in the book where she discusses it. But this is something, this is something you need to remember. Like people get stuck in that focus state and you just can't solve that problem. Take a walk, like a 5-minute walk, and then you're gonna come back with a different approach. Okay, so then the next one is going to be keeping it basic. When it comes to programming, like I said, you don't want to start just jumping into code. Where you really do want to start most of the time, if you're given like a lead code problem or like this huge undertaking, is that you want to start with pencil and paper. So that means you're not touching your keyboard. I mean, okay, sure, if you're not putting any code into your computer. You're not going to code anything yet. You're basically going to sit with a piece of paper. And like, I'm not joking with you, you're going to be sitting there, and what you're going to do is, like, let's say we had that cart example. I'm going to draw, okay, so what I'm going to do is I'm going to draw a thing here, like just a little block. I'm not even joking with you. On a piece of paper, I'm going to draw a cart, and I'm going to draw a user. Now my mind has actually got some kind of understanding what's going to happen. There's going to be a cart, and it's going to go to the user, or, maybe the arrow goes the other way. But now there's sort of some understanding of what is actually going to take place, and then maybe I can actually go and say, shares purchase. Sorry, I'm not going to be able to write that in. Just shares purchase. So now you're breaking it down. You're breaking your problem into these. Remember, like you're supposed to take a big problem and break it down. Now you are doing that, but you don't want to be sitting in front of a computer where you can easily get distracted and all of that. So sit with a piece of paper and pen and just go crazy. Draw as many of these little blocks as you can and see how they can actually fit together. And that's actually going to go to the next step with UML diagrams in a moment. So those are sort of some basic things about how I would say that you should actually be approaching your programming. So now let's just have a look at UML diagrams. I've actually got... Okay, so there's a couple of apps that you can use to do diagrams. One of them is Draw.io, which has been changed to Diagrams.net, and there's also Lucid Chart. Okay, so what we're going to be looking at is systems design. What we're looking at right now. You get UML diagrams, which is called Universal Modeling Language. I hope I got that right. And basically, what it is it's sort of like a standardized way of drawing parts of software development, and not just software development, but it's just agreed upon set of tools. Like certain arrows mean certain things, or if there's like a database, it's got a specific icon, or if it's a person, it's got a specific icon. So it's just a way for them to standardize this type of things. But I'm only going to sort of like want you to know about just a really small handful that you should try and start using as you are programming. And once again, you're going to have people saying that you don't need to be doing UML diagrams. However, I find like I do UML diagrams for every single app I build in my own private capacity. And I just, because of that whole sort of belief that your application should have actually been written without code before you even start coding it. Like you should really have your whole application planned out, knowing what it's going to do and everything. And how do you do that? You need to be using diagrams to do that. So let's start with the first one. And just by the way, I'm not teaching you the most professional way to use these that you would get flying colors in college. I don't have that enough experience to be like a proper sort of UML instructor. So I might not have the right arrows or things when I'm showing you this example here, but you don't really need it to actually make progress with it. So the first thing I'm going to show you is the should have been flowchart. Okay, so let's just go with the flowchart first. So the flowchart is, oh, please don't make me do this. So I hope I'm not going to have to sign in all of that because I have to get Bitwarden open. Go, I'll authorize it. Okay, so we might actually just have to start using diagrams that I can find online. This was working. I don't know why it's asking me now to log in again. Okay, so I guess why it is loading. A flowchart is basically the process flow of an application. This, I promise you, is so important. Like, I know this is a dumb example here, but I've had these situations where we've got these complex checkout systems. Actually, I'll tell you about a private thing that I'm building that I'm actually quite happy. Like, I'm just really proud of this. I'm building out this sort of math worksheet generator class. A thing that tool that teachers can basically share their curriculum with other teachers around the world, so that people in impoverished countries can have the same syllabus as somewhere as in America, for example. But now the system for sharing all of this information is so incredibly complex that you just can't sort of understand, like really wrap your mind around it every second of the day. So what you would generally do is you build a process like this. So you would have something like user logs in, then is verified. So is the user verified? So okay, let me actually explain the different parts of it. So you've got basically what is sort of an action in these squares over here. Then this over here is your conditional. Remember we learned about conditional? So you don't even have to be programming at this at all. You can actually be like a UI designer and start doing this. Okay, so we basically say, is user logged in? User logs in, and then is he verified? No, then we will just say, go back to landing page. And if he is logged in, then we go and say, is paid user, I guess. Then you say yes, and say show paid user screen. Otherwise, we would say show basic screen. So this has now allowed you to sort of plot your flow for your application. Now this is not the only documentation you would do. This is the one part of the documentation. Then the next thing that you'd be looking at is class diagrams. Now these are my favorite. These are I basically just draw these all the time, and it will go hand in hand with what I showed you earlier. So when I said, yeah, you draw these little blocks like this, you draw like just a little square, and you just write the name and you link it to another square. Where that comes in is that once you know those 100% what is plotting to what, you can then actually start populating it with sort of the shape of how it is going to be. So this is an example we were using here. So let's actually just play on this example here. So what you got here is a college system, and basically a person registers on that system. But a person on that system can either be a student or they can be a professor, and there can be an address data object attached to that person. Okay, so I think that's what it is. So at the top here is your variable names. Like I'm just going to go over the very basics of it. At the top here is your variable names, and then over here are the methods that will be used for this. So I generally would just go and have the actual variable names here with the data types. I would have something like, let's just say username, and I'll have a string here. Then your phone number, then have a string. This helps with when you're doing TypeScript and whatever, and then last your email address. Let's have a string, and then my method here will be something like add person. Okay, so this is literally all I'd expect you to know. Like, you don't need to know this, like how many of and all of that. This helps when you're creating databases, but you're not worrying about this. So let me just take it out. So now this person is linked to an address. I can immediately know now when I'm coding my application, do I have these fields? And does my database have those fields? So now my application, I'm planning it out on paper before I'm even having to get to code. Then there's just a couple of others which you're not really going to need to know with like user stories, unless you know, like you need to know quite a bit of theory for user stories. The last one was going to be, oh, sorry, let me just check my notes here. Use case diagrams, but I don't see it here. Okay, I'm just going to just show you a picture here. Now, once again, this is also going to sound just a bit stupid when you see the picture, but I promise you it really helps when you're trying to plot the things out and trying to understand your complex applications. So let's just go with this basic one, yeah. Come on. Okay, so all you're basically doing is it's a use case diagram, so it's like what that user is going to be doing on that system. So you can see here that you have a customer, they can view their items, make a purchase, and they can log in. They can't complete checkout. That's going to be done by different systems. So, for example, PayPal will handle the checkout system, and authentications handling their, like, I don't know the system, so I'm just trying to just make sense of it so that you can understand. But so if you had your own little app, like for example, that app we built, the richer one, that customer would have been able to check out item and then view items. So if there's just sort of one user, then this might still not make sense, but I still highly recommend you do actually build your documentation, and then as it's more complex, it'll make a lot more sense. Now, okay, so that's all the UML diagram stuff I wanted to cover. Unfortunately, like, I'm trying to squeeze a lot into a very short amount of time here. Now, if you are going to be building stuff out for your portfolio, and we start giving you more complex projects, I wouldn't expect you to go and do these diagrams, which is the class diagram and the flowchart diagram and a use case diagram. And I will summarize these later on so that you can refer back to them. I wouldn't expect you to do it. However, if you can actually do this, and then you link it on your GitHub profile, so that, for example, when you land on that page, like your landing page, that readme.md, and there's this use case diagram or a link to documentation, and there's this use case diagram and the flowcharts and all of the stuff. Like, as a potential employer, I would be greatly impressed with you. I would feel like this person puts so much effort into their work, and they try and build things right. They whole ass things, and yeah, like, so I've actually even been putting them into mine just because I do it anyways. Why not? But if you can, try and actually do documentation like this for your projects that you do get in this program. I promise you it will pay off in the long run. And especially if you start actually using this for your own benefit, so that you before you get to coding your application, you know the odds and ends, you know where you're going to get caught out, you know what problems are going to arise. And ultimately, you will end up building incredibly robust applications. Okay, so I know we've basically run out of time, so there's just a couple of last things I just want to mention here very, very quickly, and they are cliche things, but it does need to be mentioned. The first thing is exercising, eating properly, and sleeping. Like, don't neglect yourself. You will be a better programmer if you do eat properly, exercise, and sleep properly. I promise you, you will be in a better shape, and you won't snowball like bad days. Just try and like, just be in good shape and eat and exercise. I know that's cliched and it's annoying to hear that, but it's actually really important even in programming. Then don't just spend your entire life programming. You need to go out and experience life. Like I'm very, very bad example of that, but you need to go out there and race cars or, like bake cakes, whatever it is that you enjoy doing. It will actually make you a better programmer. You will open up your mind to seeing things in new ways, which ultimately will be new ways that you find solutions. So you do need to experience the world. Don't just stick to coding. And then the last one is just a bit of coding burnout. You are going to have coding burnout. It is unavoidable. And basically what happens is you spend too much time coding, too much time learning, and you just hate it. You don't want to touch it. And a burnout can last from like a couple of days to 2-3 weeks, even a month, maybe even longer than that. Like a burnout can be really bad. So try and limit that from happening. Like take breaks. Don't just grind nonstop. Otherwise, like overall in the long run, you're actually going to be doing less than if you actually spaced it out. And with that being said, don't ever give up. Don't be discouraged. This is tough, and for everybody it's tough. Like I've showed you now previously, these guys that have been doing this for years, they can't just build a thing all the way. Just their mind has just got this huge mental capacity and a million IQ for them to understand everything that's going on. They've learned to break things down into small problems. And then sure, they've probably built something before, so they've got to, they know how to do that one thing a lot quicker, but they know how to break things up. They don't just build Facebook overnight. So if you do run into problems and you like, oh, you didn't understand a certain thing and you feel dumb, don't feel stupid at all. We all go through that, even the best of the best. We're all human at the end of the day. As long as you try your best, that's what really counts. Okay, so I don't know if I missed any hands up and all of that. Sorry, I try to get so much in. I apologize if I've missed some questions. Anybody? It's been really silent. I don't even know if people are here. Does anybody have any questions? Okay.
We're here.
Okay. Has this been helpful at all? Like, to me, this is really important stuff, but then I don't know if this has been if people think it's just stupid. Okay.
I thought it was
but
helpful.
You're the only UI person here, the only non-developer.
I think so, because when you're learning development, everyone focuses on the syntax and how to get the code to do something, but there's a lot of, those are like the bricks, but there's like the cement between the bricks that you don't get from online courses. Like even silly shortcuts that you teach us, like, oh, you should fire up a live server for this. Oh, here's an emmet that you can use. Oh, why don't you just like do this on pen and paper first? So it's really helpful to hear like what are like helpful tips that make you a really productive programmer.
Thanks. That's great to hear.
Yeah.
Look, one of the things that's really important to me, and I'm not saying FEDSA, this is just something to me, is that we can't keep polluting the internet the way that we do with having developers get out there who are just looking for a job and they do the bare minimum. And basically what we end up is a lot of junk on the internet. I have sort of a responsibility that if I'm trying to mentor you, to make sure that you are also going to be quality developers that are going out to the world and you're going to be developing quality applications, especially in South Africa where the level is very low, like the bar is so low. So like Tamira, thanks. That's exactly what I want to hear, is that not just those tips, but also so that that you guys will, you all will become good developers. I don't want you to just leave here that you can get a job. I want you to be maybe not the best, but really good. Like if people say Tamira, yeah, man, she's such a great developer. And so that's something that you will be finding in the mentoring that I'm doing, is that I'm trying to make sure that you are getting a proper basis and not just doing the stuff so you can just get employed. Yeah. Okay. And if there's one thing you can take away from this, it will be that plan your programming before you even start coding. Please try and just do it. Like, not everything. At work, you're going to get given a task. You're going to have to do that task. But if you're building your own little to-do list or whatever, sit with a piece of paper and pencil. And I promise you're going to get so much quicker as you go along. And then you're gonna see that you're gonna become basically an architect. Yeah. Okay, Skulk, if you got anything, you've been sitting very silently. You got anything you would like to add for this session?
Sure, so many things, but I think I might just.
No, you're speaking.
Am I muted? Okay, it says, I don't know. I got that notification that says you are muted, whatever. So many things, but I think I might just introduce more complexity and confusion. Yeah, I think my questions I would have. So let me maybe just quickly throw two of them. I'm curious on your thoughts on this. If anyone attending doesn't really know what I'm referring to, don't worry. So first and foremost, the initial part we spoke about, naming your variables like do and whatever. I used to do that quite a bit as well, especially with Booleans. I used to say is, so is active, is open, and so forth. Have you found? Do you use static typing? Through something like TypeScript
I use
and so
TypeScript quite a bit.
Have you found that you do that less when you have static
I'm
typing?
really on a weird fence for that one, because like I've also started doing it where I say is visible, is focused, and then I find that it just seems out of place. It just doesn't seem like it's right. And so what I end up doing is I just have visible. Yeah.
Exactly. I see Tamira ask like, what is static typing, and now I'm already regretting asking that question. It's
actually a good one. Actually, I'll go back to that in a moment. Skulk, actually, since you were going to ask a question, is there anything that I think would provide a lot of value for this? Is that you just completely disagree with something I've said, so that they can see that there are opinionated ways of doing things.
Yeah. Okay. Yeah, do you want me to disagree? So I think that stepping through code encourages bad practices.
No, that's
hello.
It's, a lot of stuff is opinionated, and people need to know that they sort of need to try. And your reasoning.
No, for sure.
I actually personally use it like when I can't understand something. It really, like when I'm doing lead coding problems, I just can't understand. Like for example, when they've gone into recursion. It is so hard for me to wrap my mind around recursion when it's being used. That the only way, if you can't step through recursion applications, how do you understand it if you're struggling?
So recursion is one of those things. Like recursion is just going to be hard, no matter what. Like recursion, because recursion is one of those things where we don't have like a physical, like anything physically that represents like this concept of recursion. So like it's just mentally for our brains hard to process something like recursion. But I think in general, I find that you shouldn't rely on what I don't like about stepping through code is that it encourages you to think in terms of variables and assignment, whereas I find that it's better to think in terms of functions. So to actually, so I think the other thing is as well, if you have so like here's the thing, like I often find that like relying too much on stepping through code kind of is a crutch for not writing unit tests. If you have like really solid unit tests, then like your focus should be more in terms of the input and the output of the actual processes, and not so much in terms of the actual variables themselves. So you shouldn't when you debug, you shouldn't go, okay, what does this thing change to now? What does this thing change to now? What does this thing change to now? You should immediately go to your actual unit test and see, is it spitting out the expected thing? And think more in terms of processes instead of like states of value in your code. But like, there's so many caveats to that, and there's so much in terms of personal preference, and there's so much in terms of like, what are you actually working on? Because kind of like this variable centric way of architecting things like does work well in some cases. I find in some cases like it's a slippery slope to like kind of spaghetti code, where the fact that you can step through it is actually making the problem worse, because you're not feeling the pain of having like things that are not properly scoped and encapsulated. But yeah, like as I said, that comes with so many caveats.
Yeah,
I'm just
no,
saying that because you asked me to disagree.
No,
with
look,
you.
I would say that if people are learning, that it's learning to step through the code is like you speaking from sort of a position where you've already learned to step through code. So try and put yourself in the shoes of someone in the same position, but they've never learned to step through code. Have they possibly learned anything else along the way by learning how to step through their code? And I'd say that it's just one of those tools that a person should learn. They don't have to continue using it afterwards. And they can toss it once they do get to unit tests. But I think with our students, we're not going to have them writing unit tests sort of anytime soon. Okay. By the way, if any of you want to drop out, you're not going to be rude or anything. You are welcome to go now. This is sort of like our extra talk time, I guess. And then anything else, Skulk? Do you ever do sort of systems design and draw out diagrams for your applications?
Yeah, but I like, once again, and this is where personal preference comes in. Like, this is also kind of like just where approaches and things come in. So I think there's so many nuances to that, and I think it's important to understand that, like, just accept the fact that people are going to disagree with you, and like, you're going to disagree with loads of other people. Like Martin and I disagree on a lot of fundamental things. Justin and I disagree on a lot of, like, Justin and I have there's some very strong things on which we disagree. But I think you should always hold your own approaches and things with like a certain level of suspect. So I think that's important. So, and once again, like in the way you do like charting and so forth, I see you take like a very like what would be the word, like ontological approach. So in terms of like, what is this thing? What does it do? Like, what is its responsibilities and so forth? Whereas I think, once again, I tend to think more in terms of states. So like, there's like this nesting of like state machines all the way up and down, that are nested inside one another, instead of like clearly separated things, which is kind of like a more like OOP, like object oriented approach. But once again, like, it's also, I would say it's better to just have an approach. If you get hung up on like, is this the best way? Oh no, that guy said that you shouldn't do stepping through. Martin said you should do stepping through. Like, I think like you're getting lost in the weeds. I think first and foremost, if you just have a what would be the word? A systematic approach to these things, you're 99% of the way there. The discussions around what is the best approach is the other 1%. So don't get hung up in those type of things. Yeah, but it doesn't mean it's not fun to have those conversations with other developers. Yeah, cool.
Okay,
But yeah, no,
I think we're
all
gonna
from my
close
side.
off now. Anybody have any questions before we go? No. All right. Okay. Thank you everyone for turning up. I will get some feedback from you afterwards through Slack. Right.
Cool.
Thanks so much.
Cheers.
Bye.